Hello everyone, it is Mrs. Cinti here and I am going to teach you a little bit about solving addition and subtraction equations of algebra. For many of you this may be review, so bear with me, take some good notes, and then for the rest of you, take really good notes. So I'm combining 2.4 and 2.5 simply because they're kind of opposites of each other. We'll be solving problems like x plus 9 is equal to 21 and x subtract 3 is equal to 12. Okay, we will be using two properties today. The first one is the subtraction property of equality. Okay, and what this says, again, to remind you, is that subtracting one, like -2 from one side and from the other side, you'll always be getting, both sides will always be even. Okay, so 23 is equal to 23, so both sides of an equation is the same. When you subtract 10 from here and you subtract 10 from here, you'll have 13 and 13. And so as long as you subtract from both sides of the equations will be the same. Okay, so it says when you subtract the same number from both sides of an equation, you will have a true statement, which is what we just learned in the last section, a true statement. Okay, very good. So let's go ahead and try some of these for the first part, an addition equation, and then we'll look at the second property in a moment. Okay. So how does this apply to our algebraic lives? So go ahead and let's look at x plus 9 is equal to 20. Okay. The way that we will solve this is we will show all of our work as usual. You want to isolate the variable, okay? Isolate the variable, always. I will say this 1,000 times. Isolate the variable, meaning get that variable by itself, okay? And to do that, we have to get rid of this 9. So the opposite of 9, the way to cancel it out is we subtract 9 from this side, we subtract 9 from this side. Okay? When we do that, this cancels out, and so we get x is equal to 20 subtract 9 is 11. Okay, and then we can always check ourselves because you will always know if you have the right answer. Is 11 plus 9 20? Yes, it is. So it is checkable. Okay, let's go ahead and try just a different way that it's organized. I'm going to keep that isolate the variable here just because clearly it is extremely important. This is a very small eraser for such a big board. I know this is going to drive some of you crazy. I'm leaving some spots there, but that's just the way it goes. Okay, we're going to go green. I don't tend to like the color green, but well, this color green. Anyway, 52 plus s is equal to 37. That's a little strange. 52 plus s. So it's organized a different way. These two, the variable and this constant, are reversed, but it's the same thing. How do we isolate the variable, right? That's what you're always asking yourself. So to cancel out this 52 on this side, we subtract 52 from this side. That will cancel this out. It will leave us our s here. We subtract 52 from this side. Okay, sorry I didn't switch colors. When we do that, we get s on this side, and then 37 subtract 52 gives us a negative value of negative 15. Okay, we can check it again. Negative 15, okay, plus 52 is equal to 37. So that works out. So our solution is s is equal to negative 15. Okay, so that's how this works. We love it, we love it, we love it. Now let's look at the other property. So property number 2, I believe I wrote for you in blue. So number 2 is now the addition property of equality. Let's get it in those notes. Okay, addition property of equality, meaning when you add the same number to both sides of an equation, you will have a true statement. Okay, meaning if I have 23 is equal to 23, when I add 5 to both sides, I'm going to get 28 is also equal to 28. Yay, so it is a true statement. That's what that means. Okay, so how does that apply to our algebraic lives again? Let's look at some examples. So let's look at this. S minus 12 is equal to 5. Again, we want to isolate that variable, isolate the variable. So we want this by itself. So that means we're going to have to cancel this out. Okay, this needs to get canceled out. We are going to leave the s as it is. The opposite of negative 12 is a positive 12. So we're going to add 12 to this side, add 12 to this side. This cancels out. We get s by itself, and then 5 plus 12 is 17. Now we check 17 minus 12 is equal to 5. So it checks out. Let's try this one. X minus 121 is equal to 70. Again, we want to cancel it out. It's almost identical to this. I'll change color. Plus 121. So cancel out the negative 121 with a positive 121. So we add 121 to this side. We get I cannot read my notes, honestly. Okay, so cancel, and then x is equal to 191. Okay, and that's what we get there. Okay, and then 191 minus 121 does logically seem like 70 is going to be our answer there. Let's try another one. Let's get a little trickier here. 11 subtract m is equal to 20. Now, this is a little tricky, okay? This can be solved in a couple of different ways. One thing you want to remember is that there is a constant in front of this number right here, a coefficient, sorry, in front of this variable. So this is really negative 1m, okay? Now, isolating the variable means you're getting the variable by itself. So this negative 1 needs to go away. It needs to be a positive 1. Now, the way that you can do it before we move on to multiplication and division, because you can solve it that way, is what we can do is we can just move this negative m to this side, negative 1m to this side. So let's cancel it out on this side by adding 1m. Okay, it cancels here, and we're also adding to this side because of the property of equality, addition property of equality. So now we have 11 equals 20 plus, we can get rid of the coefficient, plus m. Okay, now we're into our addition equation again. So now we can subtract 20 from both sides, subtract 20 from both sides. We have negative 9 is equal to m. And then, of course, we check ourselves, right? We want to check ourselves and make sure that we're doing the right thing. 11, and especially when you do something tricky like this, it does not hurt to check. 11 subtract, we plug it into the original equation, which is right here, not this part, sorry, which is right here. 11 minus m, so 11 minus, and we're saying that m is equal to negative 9, which is equal to 20. So this means 11 subtract a negative 9. So keep, change means 11 plus 9, which is 20, which is 20. Perfect, it checks out. Okay, so something to pay attention to, something to pay attention to. Let's go ahead and try another example. Let's try negative 8 subtract r is equal to 15. Okay, so a similar problem just with a little bit more fun to it. So we have that negative 1r. We don't want the negative 1r. So I'm going to add r to both sides, add r to both sides. I'm going to teach you how to solve this another way later, but add r to both sides. This cancels out here. Negative 8 is equal to 15 plus r. Now we subtract 15 from both sides. We get r by itself here. It's now canceled over here. And we get negative 23. So negative 23 is equal to r. Okay, and then we can check it. Negative 8, subtract a negative 23, keep change, and we get a positive 15. So that does indeed check out. Okay, a couple more types of problems you might be asked to combine like terms while we're doing this. So just to remind you of how to do this, right? Combining like terms. Let's go ahead and remember a like term are terms that have the same variables with the same exponents. So 2m and 2m squared you cannot combine because they are unlike terms. However, 2m plus 5m you can because they are the same variables with the same exponents on them. So this would become 7m. Okay, but this cannot be combined. So this would be the most simplified version. So, for example here, 14 plus n plus a negative 2 plus 8 equals 30. Okay, so first we have to combine the terms. So, do we see anything in here? So n, there's nothing with an n here other than that one. So we'll keep the n there. But this is a term that can be combined with that and combined with that. So we can rearrange it. You don't have to. I'm happy for you to do this in your head. It just makes life easier sometimes when you rearrange it, especially if there are more than two terms that you're combining. So 14 plus a negative 2 brings us down to 12, plus 8 is 20, plus n is equal to 30. And then we isolate the term, so we subtract 20 from this side, subtract 20 from this side, and we get n is equal to 10. Okay, and then we can plug it back in. 14 plus 10, okay, is 24, minus 2 is 22, plus 8 is indeed 30, so that checks out. Okay, let's go ahead and add an exponent to it. So let's say that the problem is 11 equals y subtract negative 4 squared. Okay, this exponent right there is telling us that we are duplicating what's in the parentheses. So if we rewrite it, we would do 11 equals y minus negative 4 times a negative 4. Okay, that's what that squared is saying. It's saying multiply this by itself. So 11 equals y subtract a negative 4 times a negative 4 is a positive 16. And so then we get 11 equals y minus 16. And so then we have to isolate the variable, cancel, add 16, add 16. We get 27 is equal to y. And so the question is 20, we can plug it in here. We could plug it in up here too, but since we simplified this, we didn't do much other than simplify this, we can go ahead and plug it into this. 11 equals 27 minus 16, and yes, indeed, that does check out. One more tricky one, and then I'll set you free. Negative, absolute value of negative 8 equals f minus 13. Okay, so we will, this is saying the opposite of the absolute value of negative 8. So opposite of 8 is equal to f minus 13. We add 13 to both sides to isolate the variable. Oops, sorry. Add 13, cancel, f equals negative 13 plus a negative 8 is 5, 5f. So is f 5 as f? If we put 5 here, subtract 13, is that equal to negative 8? And the answer is yes, it is. So we're always checking ourselves. Okay, good luck. I will see you with lots of practice at school.